Namaste to all. Welcome to my channel MA Tuitions. If you are watching my channel for the first time, don't forget to like, share and subscribe. Just press the bell button, then only you will get the notifications properly. Today we are going to start a new lesson, chapter 2, Polynomials. Suppose you have a playground which has an area 200 meters square. Okay, it's rectangular in shape and the length is 20 meter. You want to change the area of the playground without changing the length. Can you consider the situation? These type of situations can be held on with the polynomials. Okay. So we are using in our daily life many times the polynomials, but we don't know how it's using. Okay. So let's move on to the chapter. First, what is polynomials? Okay. What is meant by polynomials? In your 9th class, you have studied about polynomials. You know well, which is a combination of numbers and the variables which are separated by the operations plus, minus, into and out. And one more thing, the polynomials, the power of the polynomials or the variables in polynomials must be a natural number. Do you remember? For example, if you have a polynomial just like x raised to 3 plus 2x plus 5, is this a polynomial? Yes, of course, it's a polynomial since this is a polynomial with the highest power 3. It's a natural number. Here also x has a power 1, which is also a natural number. So we can say that's surely a polynomial. So this polynomial is a polynomial which has only one variable. Am I right? This is a polynomial in one variable. Another situation or another polynomial, just listen. Y square plus 2y plus 1. Is this a polynomial? Yes, this is also a polynomial since there are only one variable y square and y. The power of y is 2 and here the power of y is 1. So this is also a polynomial. One more situation, x raised to 3 by 2 minus 3. Is this a polynomial? No. What's the reason? Since the power of x is 3 by 2, this is not a natural number. Not a natural number. This does not belong to the natural set of natural numbers. So we cannot say that this is not a polynomial. One more. If you have another polynomial, root z plus 3 minus 2z. What about this polynomial? Root z plus 3 minus 2z. Here the power of z is 1, but here the power of z is root 2 means it's 1 by 2. This is not possible. So this is not a polynomial. This is also not a polynomial. Another one. If you have 1 by y plus y square plus 2. What about this? Here 1 by y means y raised to negative 1. Am I right? Plus y square plus 2. Here negative 1 is not belongs to the set of natural numbers. So we cannot say that this is not a polynomial. I think you understood about the polynomials. Let's move on to the degree. That also you have studied in your 9th class. What is meant by degree? Degree is the highest power of the polynomial. What is that? Degree is the highest power. Highest power of the polynomial. Highest power is known as the degree. So come to this example. Here x cube plus 2x plus 5. This is a polynomial. So we can find the degree of this polynomial as the highest power of x is 3. So degree is 3. What about this? The highest power is here 2. So here the degree is 2. These two are not polynomials. These three are not polynomials. So we cannot say the degree of, we cannot say anything about the degree of this. Got it? So from this we can classify our polynomials according to the degrees. Okay. We can classify the polynomials according to their degrees on the basis of their degrees, which are as follows. Let's listen. Let's listen to the examples. If you have 2x plus 5, one example is 2x plus 5. Another one, 3x square plus 5x plus 1. Another one, 4x cube plus 2x plus 3. I have written 3 different types of polynomials here. What is the degree of this polynomial? The degree of this polynomial is 1. Am I right? Here the highest power is 1. What about this? The degree is 2. Here the degree is 3. So on the basis of their degrees, we can classify this polynomial as, if the degree is 1, we can say this polynomial as linear polynomial. What is that? Linear polynomial. If the degree or the highest power is 2, then we can call this as quadratic polynomial. This is a quadratic polynomial. Here the degree is 3, so we can call it as cubic polynomial. Okay, cubic, quadratic and linear. Much more is there, so we need just this much. Okay. So the first degree polynomials are known as linear, and the second degree polynomials are known as quadratic, and the third degree polynomials as cubic polynomials. So can you write the general equation for this? Yes, of course. We can write this as ax plus b, where a cannot be equal to 0. What is meant by this a cannot be equal to 0? If this a is equal to 0, then you will get 0 into x plus b, which will be b. B is a constant. This is not at all a polynomial with degree 1. Am I right? So this is a must condition. It should be there. Otherwise, it's not good. It's not right. Okay. Whenever you are writing the general equation of a polynomial, you must write that a not equal to 0. What about this one? Here also ax square plus bx plus c, where which cannot be equal to 0? A. A cannot be equal to 0. B or C, that's not at all bother about any terms B and C, but it should be specified that A must not be equal to 0. Then only you will get a quadratic polynomial. Here also ax cube plus bx square plus cx plus d. This is the general equation or the general polynomial where A must not be equal to 0. So these three are the different classifications of polynomials according to their degrees. If the degree is 1, you can say that it's a linear polynomial. If the degree is 2, it's a quadratic polynomial. And if the degree is 3, you can say that it's a cubic polynomial. Understood? Next, how to name a polynomial. I think you have already studied. No problem, we will consider how to name a polynomial. How to name a polynomial. If you have given some polynomial just like 2x raised to 4 plus 5x cube minus 3. Is that a polynomial? Yes. Since this is a polynomial in which only one variable is there. What is that? It's x. So we can name this as p of x or q of x or r of x. Whatever may you like, you can use. Okay. That means we are using the small letters. In English alphabet, the small letters we are using for this, and which is the variable in this polynomial that we are putting here. Got it? So I am using this as p of x equal to 2x raised to 4 plus 5x cube minus 3. If you are given some another polynomial 3y square minus 3y square minus 8, you can write this as p of y or q of y or r of y, just like that. Then what about if you have given some 3t square plus 5t minus 1. You can write this as q of t or p of t or r of t, just like that. Next, what you want to find? How to find out the value of a polynomial. How to find the value of a polynomial. Just listen. If you have a polynomial which is named as p of x equal to 3x square plus 5x plus 1. If this is your polynomial p of x, you want to find out the value of these polynomials when you are given x as 1. When x equal to 1, we will put, instead of this x, we will use the value 1. So we will find out an answer for this p of x that will be the value of that polynomial at that point. Okay. When we are substituting this 1 for this x, so it will be 3 into 1 square plus 5 into 1 plus 1, it will be 3 plus 5 plus 1, which will be 9. Okay, got it? You want to find out the value of this polynomial when x equal to 0. So it will be p of 0 equal to 3 into 0 square plus 5 into 0 plus 1, which will be 1. When x equal to negative 1, it will be p of negative 1. You can write just like this, 3 into negative 1 whole square plus 5 into negative 1 plus 1. This will be 3 minus 5 plus 1. 3 plus 1 is 4. 4 minus 5 is negative 1. Okay, so these all are the values of a polynomial. Consider another example where q of x, I am writing this as q of x equal to x square minus 3x minus 4. Find out the values of this polynomial when x equal to 0, 1, negative 1. So first we will substitute x equal to 0, so it will be q of 0. 0 square minus 3 into 0 minus 4, which will be negative 4. Okay, what about q of 1? It will be 1 square minus 3 into 1 minus 4. 1 minus 3 minus 4. 1 minus 7, which is equal to negative 6. Okay. Then what about q of negative 1? Which is equal to negative 1 whole square minus 3 into negative 1 minus 4. Negative whole square is 1. Negative positive minus 4, which will be 4 minus 4 equal to 0. So in this case, when you are substituting for x equal to negative 1, you got the answer as 0. Okay, whenever you are getting the value of the polynomial as 0, that value of x is known as the 0 of that polynomial. Got it? So here x equal to negative 1 is the 0 of the polynomial. 0 of the polynomial. Okay, what is meant by 0 of the polynomial? Whenever you are getting the value of the polynomial as 0, that value of x is known as, or that value of that variable is known as 0 of the polynomial. Got it? If you have another p of x is equal to 2x minus 3. Consider this polynomial p of x equal to 2x minus 3. So can you find the 0 of this polynomial? Which is very simple, 2x minus 3 should be equal to 0. Am I right? Then only you will get the polynomial. Then only you will get the 0 of the polynomial. So you can substitute this 2x minus 3 as 0. Then you will get 2x equal to 3. Then x equal to 3 by 2. So here 3 by 2 is the 0 of the polynomial. So in general we can say that if you have a polynomial ax plus b, you have a linear polynomial which ax plus b where a not equal to 0, then the 0 of the polynomial will be ax plus b equal to 0. We have to substitute just like this. Then ax equal to negative b you will get, then x equal to negative b by a. So in general we can say that for any linear polynomial ax plus b, the 0 of this polynomial will be negative b by a. Negative b means it's a constant, negative of the constant term. Am I right? Negative of the constant term by a means the coefficient of x. Coefficient of x. X means the variable, coefficient of the variable. Here it is x, so we can write just like this. Got it? For any linear polynomial ax plus b, we can say that the only one 0 of this polynomial is negative b by a, or the negative into constant of term by the coefficient of the variable. Is this possible, or is this condition is correct to all the polynomials, all the quadratic, cubic and all? No, it's not. It may not be equal to. It may not be equal. So we can find what is meant by the 0 of the polynomial, or how many zeros will be there for this linear, quadratic and cubic polynomials. That we are going to find out. Okay. So we can conclude just like this. A real number k is said to be a 0 of the polynomial p of x if p of k equal to 0. What's meant by that? Whenever you have find k as the 0 of some polynomial p of x, then this p of k must be equal to 0. For example, if you have a polynomial 4 minus x, you have a polynomial p of x equal to 4 minus x. And you find out that this x equal to 4 is the 0 of this polynomial. What is that? X equal to 4 is a 0 of this polynomial. Here, instead of this k, we can use this 4. Okay. Then p of 4 must be equal to 0. P of 4 must be 4 minus 4, which is equal to 0. Got it? Whenever you have a real number k, that means here it is 4, is said to be a 0 of this particular polynomial, then that particular polynomial must do like this: p of 4 equal to 4 minus 4, which is equal to 0. So in other words, we can say that a real number, you having one real number k, and if p of k equal to 0, then k is a 0 of this polynomial. Understood? Next we have one example. Find the 0 of the polynomial 5x minus 4. The polynomial is p of x equal to 5x minus 4. We want to find out the 0 of this polynomial. We have just studied a concept just like this. Whenever you are having a real number k and which is the 0 of this polynomial, then p of k must be equal to 0. So here also we can write like this. P of k must be equal to 0. Then we can say that k is a 0 of this polynomial. Okay, whenever you have given some polynomial and you want to find out the 0 of this polynomial, what we want to do? We will assume that this whenever we are substituting k for this x, we got the 0 of that polynomial as k. So we are substituting instead of x as k, and you will write q for 5k minus 4 equal to 0, and taking this negative 4 into that side will be positive, 5k equal to 4, and then k equal to 4 by 5. So 4 by 5 is the 0 of this particular polynomial. Next we will move on to find the geometrical meaning of 0. So we have studied up to this what is meant by 0 of the linear polynomial, quadratic polynomial and cubic polynomial, etc. Then what does it mean? In geometry, how can you explain the 0 of these polynomials? First one, we will take the linear polynomial. Okay. Now consider a linear polynomial y equal to 2x plus 3. You want to draw a graph according to this polynomial. How can you find out? We will make a tabular column. In this you will substitute the values for x and y, then you will get the answer, isn't it? So whenever you are substituting for x, you will get answers for y. I am going to substitute 0 for this x. It will be 2 into 0 plus 3, it will be 3. And what about it will be for, if it is x equal to 1, you will get 2 into 1 plus 3, it is 5. Then 2 into 2, 4 plus 3, it is 7. What about negative 1? Negative 2 plus 3 is 1, and negative 2, then it will be negative 4 plus 1, which is negative 1. Okay, so these are the values. According to this, we are going to draw a graph. Then only we can find the geometrical meaning of this linear polynomial. So I am going to draw a graph. Here is your graph. We are going to plot the points in this graph. First point is 0, 3. So it will be 0, 3. This is your 0, 3. Then next is 1, 5. So this will be your 1, 5. 1, 5. Okay, this will be 1, 5. Then next 2, 7. You are going to plot this 2, 7. Here just like this. 2, 7. Then negative 1, 1. Negative 1, 1 is this point. This is negative 1, 1. Here is negative 1, 1. Okay. Then negative 2, 1. Negative 2, negative 1. This is negative 2, negative 1. So we can draw the graph just like this. By drawing all these points together, you will get a line just like this. This is negative 2, negative 1. So you're getting a line just like this, and all the points are in this. You can find in 2 points this line intersect with the axis. This is the line y equal to 2x plus 3. This is the graph of y equal to 2x plus 3. And this line intersects with the y-axis and with the x-axis in 2 points. Am I right? And here is the point 0, 3. And one more point here is, it is between negative 2 and negative 1. Okay. So whenever your line is intersecting with the x-axis, that point will be your 0. We can check. How can you find out the 0 of this polynomial? By substituting y equal to 2x plus 3 is equal to 0. Am I right? 2x plus 3 equal to 0. Then you will get 2x equal to negative 3 and x equal to negative 3 by 2, which is negative 1.5. Which is in between this negative 2 and negative 1. So this will be your 0. This is a linear polynomial. So you will get only one solution or only one 0 for this polynomial. And that 0 is this point negative 1.5, and which is in between negative 2 and negative 1 in the x-axis. But we have got another point 0, 3 on this y-axis, but this is not the 0 of this polynomial. Whenever you are getting a 0 in this whenever your line is intersecting or your graph is intersecting with your x-axis, that will gives the 0 of that polynomial. Okay, so your 0 of this polynomial means negative 1.5. So what is the geometrical meaning of this graph or the linear polynomial? Linear polynomial have only one solution, only one zero. Okay, only one zero is there for the linear polynomial. And how can you find out that zero of the polynomial? Whenever you are drawing the graph of this linear polynomial, you will get a straight line. You will get a straight line. That straight line will intersect with, sometimes may with x-axis and with y-axis. Whenever you are getting a graph which is intersecting with the x-axis, that point will give you the zero of that polynomial. Next, we are going to find out the geometrical meaning of quadratic polynomial, and you have quadratic polynomial which is x square minus 3x minus 4. Here also we want to draw a tabular column and to plot the points on that graph. Okay, then we have substituted some values, assigned some values for this x, negative 2, negative 1, 0, 1, 2, 3, 4. When you are substituting this negative 2 for this, it will be 4 plus 6 minus 4, it will be 6. And if we are substituting for negative 1, it will be 1 plus 3 minus 4, it will be 0. Then what about 0? This will be negative 4. Then you are substituting 1 minus 3 minus 4, it will be 1 minus 7, negative 6. And if you are substituting 2, it will be 4 minus 6 minus 4. 4 minus 10, it will be negative 6. Here substituting for 3, it will be 9 minus 9 minus 4, negative 4. 4 will be 16 minus 12 minus 4. It will be 0. So have got 2 points as 0, negative 1, 0 and 4, 0. So we will plot these points on that graph. Then you will get a graph. Okay, negative 2, 6. It will be negative 2, 6. Somewhere here. Sorry. This is negative 2. Shall I take the scale? This will be negative 2, 6. Then negative 1, 0. Negative 1, 0 is this point. This is negative 1, 0. 0, negative 4. This is 0. 0, negative 4 is here. 0, negative 4. Then 1, negative 6. 1, negative 6 is here. 1, negative 6. Then 2, negative 6. 2 and negative 6. Here is 1, negative 6. This is 2, negative 6. Then 3, negative 4. It will be 3, negative 4. This is the point. 3, negative 4. And one more. 4, 0. 4, 0 is this point. This is 4, 0. We can draw a graph just like this. This will be a curve. See this? This is a U-shaped curve. Am I right? This is a U-shaped curve. Okay. This curve can be, this is the U-shaped curve. This curve can be known as parabola. Have you heard this name before? This is known as parabola. So whenever you are drawing a quadratic polynomial into a graph, it will be a parabola. Sometimes it may be open upward, sometimes it will be open downward. Sometimes you may get a parabola just like this, or you may get the parabola just like this, according to whether a is greater than 0 or whether a is less than 0. You know the general equation for the parabola, the quadratic equation, quadratic polynomial, which is ax square plus bx plus c ax square plus bx plus c, where a not equal to 0. According to this a, if it is positive, this parabola will be open upward, and if this a is negative, then you will get a parabola downward. Okay, so you have got 2 points on this x-axis which is meeting, intersecting with this parabolas, and x-axis, this negative 1, 0 and 4, 0. So these 2 points are the zeros of this polynomial. Okay. So you can say just like this, for every quadratic polynomial, because this degree of x is the maximum degree, or the maximum power of x is 2, it has 2 solutions or 2 zeros which are negative 1, 0 and 4, 0. Got it? So that is the geometrical meaning of this quadratic polynomial. So we have studied that whenever you are drawing a graph of quadratic polynomial, you will get a parabola. Surely you will get a parabola. It may be of these 6 types. Okay. In the first case, you can see that this parabola is intersecting with the x-axis, positive direction of x-axis. That means it gives 2 solutions, that it will be a positive one, positive number you will get. This gives a 2 solutions or 2 zeros for this polynomial. What about this case? In this parabola is intersecting at the positive and negative direction of x-axis. So here also you will get 2 solutions or 2 zeros for the polynomial, and what will be positive and the other will be negative one. Okay, this has 2 solutions. What about this case? Here only one time it meets with the x-axis. So we are getting only one solution. That's not correct. The solution will be the same. For the quadratic polynomials, you will get surely 2 solutions, and the 2 solution will be the same number or the same value. That's why we are getting just like this. Both the cases are giving the same answer to the quadratic polynomial. Okay. And what about these 2 conditions? These 2 parabolas are not at all intersecting with the x-axis, only intersecting with the y-axis. So it will not give any solutions to the quadratic polynomial. So this will not give any zeros to the polynomial. Got it? Here is our cubic polynomial. We are going to find out the geometrical meaning of this cubic polynomial. I had written one polynomial here, p of x equal to x cube minus 4x. And we want to find out the points, and we have to plot that on that xy plane or that graph. Okay, first we are substituting this negative 2, it will be negative 8 plus 8, it will be 0. So negative 2, 0. Then negative 1 will be negative 1 plus 4, it equal to 3. Okay. Then 0, it will be 0, and 1 minus 4, negative 3. And if you are substituting 2, 2 cube is 8, 8 minus 8 is 0. So here you got 3 zeros. Since the largest, the power of this polynomial or the degree of this polynomial is 3, it must include 3 zeros. Okay, at most 3 zeros should be there. So we got negative 2, 0, 0, 0 and 2, 0, 3 zeros. So if you are plotting these points in this graph, the curve must be intersect the x-axis in 3 points. At least 3 points, at most 3 points, which are negative 2, 0, 0, 0 and 2, 0. We will plot these points on that graph. Then you will get negative 2, 0 is here, and negative 1, 3 will be, negative 1, 3 will be here. Then 0, 0 will be here. Then 1, negative 3 is somewhere here, 193. Then 2, 0 is here. So we will get the graph just like this. Okay, this will be your graph. Okay, this is your graph. So in these 3 points, the curve and the x-axis intersect, isn't it? So we have got 3 points, maximum 3 points for the cubic polynomial. So that is the geometrical meaning of this cubic polynomial. So you have studied about the geometrical meaning of different types of kinds of polynomials, especially linear, quadratic and cubic polynomials. This is exercise 2.1. Only one question is there. The graph of p of x is given. A polynomial p of x is there. We have drawn some graphs according to that. It is given on their textbook, and we want to find how many zeros are there for each of these graphs or each of these p of x. So we know that how to find out the number of zeros from a graph. How can you find out? You check whether the given line or the given curve is intersecting with the x-axis in how many points. That number gives you the number of zeros of that polynomial. Okay. In the first case, this is a parallel line. This line never intersects with this x-axis. So there is no zeros for this polynomial. Okay. What about this one? Here only one. At one point, this curve and the x-axis intersecting. So 1 0 is there for this polynomial. What about the third case? Here 1, 2 and 3. In 3 points, the curve and the x-axis are intersecting. So we can say that here 3 zeros are there. So it will be a cubic polynomial. What about this? Here also 2 points are there. You can see here 2 points on the negative direction of x-axis. So here you will get 2 zeros. Here 1, 2, 3 and 4. Here 4 zeros will be, can you take this point? No, since this is the y-axis, so you cannot find any zeros on this. You have to find out whether the curve is intersecting with the x-axis, only the x-axis. So here 4 points are there, so you can find 4 zeros for this polynomial. What about this? Here 1, 2 and 3. So only 3 zeros are there for this polynomial. So our exercise 2.1 is over. Today we have discussed about the polynomials and how to find out their degree and how to classify the polynomials according to their degrees, and what is the geometrical meaning of linear polynomial and cubic polynomial, quadratic polynomial. I think you all understood all these things, and just go through the chapter and do the exercise by yourself. If you have any doubt, please make it on my comment box, and please like, share and subscribe. Don't forget to watch the following videos. We will see you on the next video with the next topic. Thank you so much.